I am the Tofu Golem. Please enjoy the video.
You begin by opening a box and confirming the part is visible and active. Next, enter the mesh module and choose seed part or seed edges to apply an initial mesh size. Set a global seed value, for example 1, 0, and pick a distribution such as uniform. This first step controls element density. Smaller seed creates finer mesh. Once done, inspect element shapes briefly so you don't proceed with distorted geometry that will affect analysis accuracy. Now refine the mesh by targeting critical regions. Use seed edge to reduce element size locally and choose appropriate element types like C3D8 for solids or C3D4 for tetrahedra depending on geometry. Make sure to set mesh controls, structured or free and sweep options to guide element alignment. If necessary, partition the part to isolate areas needing finer resolution. Partitions let you apply different seeds and controls. This approach balances accuracy with compute cost so you get quality results without excessive elements. Finish by generating the mesh and running the element check to confirm quality metrics like skewness and aspect ratio. If you find distorted or poorly shaped elements, use refinement or coarsening tools, remesh the affected partitions, or change element type to improve behavior. Make sure to rerun checks after changes and preview mesh-based results. Troubleshooting tip: if persistent errors occur, reduce seed size by 20 to 50% and simplify problematic geometry so elements can form cleanly and reliably for the solver.
Thanks for watching. Consider subscribing if we helped you today.